Assalamualaikum warahmatullahi wabarakatuh. Honorable Committee and all participant conference. I am Rosmina from Faculty of Agriculture and Animal Science, State Islamic University of Sultan Syarif Kasim Riau. Today, I want to present our research with the title Mutation Induction in the Vine Ananas comosus elmer using colchicine. To background our research, pineapple is one of the tropical fruit with high economic value after banana. One of the pineapple producing area in Indonesia is Riau province, where the pineapple cultivation in the peatland. Some of the problems in pineapple cultivation are the varying fruit size and spinach on leaf. Fruit size is the primary standard determining the price of variety in the market, while the spinach make difficult to the cultivation process. The ideal type of pineapple desired by farmer and canard fruit industry and consumer is uniform size, good taste, and non-spinous leaf. The improvement of pineapple can make through conventional breeding program by crossing or mutation induction, but conventional breeding in pineapple was difficult because it was highly cell incompatible. The selfing of pineapple never produce seed, while cross between different cultivar, the obstacle that arise in different in flowering age between cultivar so that breeding through mutation is the main alternative for pineapple plant. Colchicine is one of the mutagenic substances used in polyploidization process. Colchicine works by inhibiting the formation of chromatin spindle during cell division, which causes chromosome doubling in the cell. Polyploid induction has been implemented on many plants like watermelon, soybean, onion, and strawberries. The aim of this study was to induce diversity in variable by collocation mutation. We divided into three purposes, that is, response of several variable genotypes to various concentrations of collocation, to determine the concentration the collocation which is able to induce mutation in variable band and interaction between genotype to collocation concentration. Material and method. The experiment was laid out following factorial completely randomized design with two factors. The first factor is for genotype, that is Saskatchewan, Bubur, Gemilang, and Bangka, and the second factor is colchicine concentration. Each treatment is consisted of 5 lines of pineapple so that there were 18 experimental units. The application of colchicine was carried on the pineapple subtype according to the concentration of the treatment. The parameters observed were plant height, leaf number, width of leaf, number of stomata, stomatal length, and stomatal width. Result and discussion. Genotype and interaction between genotype and colchicine concentration significantly different in plant height and number of leaves. The Bangka genotype had the highest plant height in the control plant at 18.77 and the Gemilang genotype had the lowest plant height was 55.64. This is table 1. The colchicine treatment significantly reduced plant height in the three genotypes, Suska, Bubur, and Bangka. The Gemilang genotype have increased in the number of leaves due to colchicine treatment. The percentage reduction in plant height was different for each genotype test. The high significant decrease in plant height was found in Bangka genotype at 0.04% of colchicine, that is 14.4%, lower the control plant. Genotype Gemilang increase in plant height was 26.67 at 0.05% of colchicine concentration. The number of leaves was influenced by concentration of colchicine and genotype used. The number of leaves significantly decreased in Bangka and Susquehanna, but increased in Bubur and Gemilang genotype. Gemilang genotype has the highest number of leaves was 48.89 at 0.05% of colchicine, or increase of 13 leaves compared to the control plant. In contrast, the most significant decrease in leaf number occurred in Bangka genotype, namely 20.11% at 0.04% and 0.05% of colchicine concentration. Colchicine treatment increased stomata size up to 5% greater than control plant. Individual 2. Identification of diversity in plant can be seen from change in stomata. The number and size of stomata have been widely reported to indicate polyploid plant due to colchicine treatment. The increase in stomata size is closely related to polyploid induction. Cell size and occur due to the polyploidization process, which cause organ growth to become more prominent. Abelo et al. Report that 0.05% colchicine increased stomata length in tomato plant. In addition, colchicine treatment at 0.0% result in tetraploid plant in grape, report by Merr et al. 2018 and Tiwari et al. 2012. From the date plant height, number of leaf, and stomata size, it can be definable with 0.05% colchicine treatment increase plant height, number of leaf, and stomata size. The genotype used have significant effect on leaf width, number of stomata, and stomata width. Bubur genotype had the large leaf size. In contrast, Gemilang was genotype with lowest leaf, which was significantly different from Bangka and Susquehanna genotype. The conclusion, based on the result of this study, is concluded that an interaction between genotype and colchicine concentration change in pineapple morphology. Different genotype responded different to the concentration of colchicine. The concentration of 0.05 colchicine increased plant height, the number of leaves, and increased stomata length in the Gemilang genotype. Since the observation was carried in the vegetative phase, the study suggested observing the level of diversity and change in morphology of the fruit and fruit quality. Thank you for your attention.